Good morning. It is Wednesday at 11:30, and I am sitting on my screen porch listening to the rain. Had to get out of the house, so hopefully the rain and thunder are not too much of a distraction. What I wanted to do was take a little bit and go through some of the problems from last week's lessons, the independent and dependent events and combinations, permutations, and factorials, because a few of you told me that you had some trouble. A few of you didn't even turn it in, but I've got those where I can pull them up. So let me see if I can do that. Okay, I hope you can see this. This one is the independent and dependent events. We'll just work several of these, okay? Hal tosses a quarter 3 times, we're on number 1. What is the probability that the result will be tails every time? Now I'm gonna kind of go back and forth between this screen and a whiteboard when I need. So let me go to my whiteboard. Whoops, that's not what I wanted. Go to my whiteboard. Okay, so he's gonna flip a coin 3 times. What's the probability that it's gonna be tails every time? Well, what's the probability that it's gonna be tails the first time? What's gonna be 1 out of 2? What's the probability it's gonna be tails the second time? Now remember, what happened the first time has no bearing on what happens the second time. If I flip a coin and I get tails the first time, that has no bearing on what I get when I flip the second time. So those are called independent events. One has no bearing on the other. So the second time I flip, I still have a 1/2 or 1 in 2 chance of getting tails. And I have the same the third time. So you multiply those together. 1/2 times 1/2 times 1/2 is 1/8. I have a 1 in 8 chance of all of those 3 flips being tails. Now I want to show you another way you can think of that. Let me clear drawing. Okay, you could think about it like this. I'm going to draw a tree diagram. The first time I flip, I could get whoops, I could get heads, or I could get tails. Now, what if I got heads the first time? Now the second time, if I got heads the first time, the second time I'm either going to get heads or I'm going to get tails. If I got tails the first time, then the second time I'm either going to get heads or I'm going to get tails. Now the third time, if I got heads the first time and heads the second time, then the third time I'm going to either get heads or I'm going to get tails. Again, the third time I'm going to get heads or I'm going to get tails. Heads or tails. Heads or tails. Now the question is, how many outcomes do I have there? I wonder if I can change the colors. Yeah, I don't know if I can change the colors or not. I'll have to play with that sometime else. I have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. So 8 is my denominator. Now, how many of those are all tails? Well, the only piece that's all tails is this one right here. Every other stem is going to have a tail in it. I mean, a head in it. So I only have 1 chance out of 8 of getting all tails. So it's just another way you can think about it. Now let's go back. Let's look at number 3. There are 3 apples and 5 oranges in a bag. Determine the probability. So let's look at number 3. 2 apples when they are chosen at random without replacement. All right, so let's go back to the, oops. Let me see here. Let's go back and find my whiteboard again. Okay, we've got 3 apples and we've got 5 oranges. So how many pieces of fruit do we have in the bag? Well, we got 8 pieces of fruit. Now, what is the probability that I'm going to reach in that bag and pull out an apple? Well, I've got 3 apples, right? So the probability that I'm going to reach in there and pull out an apple the first time is 3 out of 8. Now, did that say without replacement, or I think that said without replacement? Without replacement means I am not going to put that first apple that I drew out. I'm not going to put it back. So there are only going to be 7 pieces of fruit in there when I reach in to draw the second piece of fruit. There are only going to be 7 pieces because I didn't put the first piece back. Now, if I drew an apple out the first time, there are only going to be 2 apples left in that bag. So I only have a two chances out of 7 to get an apple the second time. So we're going to multiply those together. Now, you can multiply straight across and simplify, or you can do some simplifying right now. 2 goes into 2 once, 2 goes into 8 4 times, and if I multiply across, I get 3 out of 28. That is the probability that without replacement, I will draw 2 apples. Now, let's talk about independent or dependent. Does what I do here depend on what I did here? Sure. I did not replace that apple, so the number of pieces of fruit that I had in the bag changed. So that's why this was dependent, because what happened the first time did impact what happened the second time. Now let's go back. Where's my thingy? Oops, wrong one. Oops, wrong one again. There we go. Okay. Do you want to do number 4? What is the probability of selecting an orange and then an apple when they are chosen at random without replacement? So see if you can do this one with me. Without replacement. All right, let me see if I can on the whiteboard. Whoops. Okay, it's not going to let me do that. Okay. Remember, in the bag, I had 3 apples and I had 5 oranges. What is the probability that I reach in and pull out an orange? Well, I have 8 pieces of fruit to choose from, and 5 of those are oranges. Now, remember, that first piece of fruit I pull out, I don't put back. So I only have 7 pieces of fruit to choose from the next time. Now, what is the probability that I reach in and pull out an apple? Well, there are 3 apples in there. So 3 out of 7. Because I only had 7 pieces of fruit left because I pulled out, I hope, an orange and didn't put it back. So there are only 7 pieces of fruit in the bag. I don't have any simplifying I can do, so I'm going to have to multiply straight across. 15 out of 56. That's the probability that you're going to reach in, pull out an orange, not put it back, and then reach in and pull out an apple. Okay, let's see what we need there. Oops, leave. Sorry. Oops. Okay, I think I messed up there. Let's go to the second page. I got the wrong one again, didn't I? Well, snap. Ugh. I think I messed up. Well, let me see here. Okay, let me see if I can do this. So just take a short break. Oh, no, I'm not going to be able to show you that, I don't think. Okay, so hopefully that helped. Come on, Stennett. Here's what I'm going to do. I'm going to stop this video, and then I will make another one on the combinations and permutations, because I think I messed up my tabs, and I don't want to take the time with you just having to waste sitting waiting for me to get it done. So this is the part on combination, excuse me, on independent and dependent events. And then we'll come back and do permutations and combinations in a minute.